What we are trying to do here is generalize a rule for a to the power 0, where a is any base. So we have to remember that when we have a power and we have an exponent just stands for repeated multiplication. So 2 to the power 1 is just 1, 2. And of course 1, 2 is just plain old 2. When we have 2 to the power 2, that's 2 times 2. In other words, 2 times itself twice, and we get 4. 2 to the power 3 is 2 times 2 times 2, 3 times, which gives us 8. 2 to the power 4 is 2 times 2 times 2 times 2, 4 times, to give us an answer of 16. For 2 to the power 5, we write down 5 2's being multiplied by one another, and that gives us 32. And last but not least, 2 to the power 6, we write 2 times 2 times 2 times 2 times 2 times 2, which gives us 64. So now what we want to try and do is find a way to figure out what 2 to the power 0 is. What we have to try and do is see if we can see a pattern in the table. How do we go from 64 to 32, 32 to 16, 16 to 8, 8 to 4, and 4 to 2? Is there something that we do on each one of those steps that we can also do to find out what 2 to the power 0 is? Well, there is, because if we divide each of those numbers by 2, we get the number below it. 64 divided by 2 is 32, 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4, and 4 divided by 2 is 2. So now, if we divide 2 by 2, we find out that 2 to the power 0 is 1. So now what we see is that a to the power 0 equals 1 for any value of a except 1. A can't be 0.